Okay, so I'll be doing the Dijkstra's algorithm. This is known as the single source um, algorithm. Okay, so it's also known as the greedy algorithm. Okay, and each time you do this, you're trying to figure out the minimum spanning tree. Okay, so how do we do this? So for MST, minimum spanning tree. Now these are the edges and these are the vertices. So we are trying to figure out what would be the best way to go from one vertex to the next. So it's like using the GPS system. So in this case, from A to A, I'm going to put a 0 there. That means coming down from A. Now I'm going to box it. When I box it, that indicates that you have already visited that. You can't go back to that vertex. Now, what's the distance from A to B? A to B, it's actually 8. So I'm going to put that 8. How about A to C? That's a 2. So I'm going to put 2 coming from A. A to D, it's actually 5 coming from A. Alright, now A to E, there is no direct link, that's infinity. A to F, that's also infinity, there is no direct link. A to G, there is A to G, that's also infinity, there is no direct link. Now A to H, it's also, there is no direct link. Okay, so this is my first pass. So now we're done with the vertex A. Now there is B, which is 8 coming from A, 2 coming from A, 5 coming from A, infinity, infinity. 2 is the cheapest, the least cost. So I'm going to bring down the 2 and I'm going to circle it. I'm going to box it. When I box it, that means I can't go back to that vertex. What is the distance from C to B? C to B. C to B, there's no direct connection, so I'm just going to, I have 8, I'm going to bring down the 8. Now C to D, C to D, there is a 2. So 2 plus 2, which is 4. Well, 4 is cheaper than 5. So I'm going to put, so C to D is 2 plus 2, or A to C, C to D, that's 4. Now C to E, it's 5. 5 plus 2, that's a 7, which is better than infinity. See that? That's A to C, C to E. 2 plus 5, which is 7. C to F, no direct link. C to G, no direct link, so leave it as infinity. And C to H is the same thing. I'm going to leave it like that. Okay, that's my second pass. So now I have 8. C going to B, well, it's 8, and that's a 4, that's a 7. Well, 4 here is my cheapest or least value, and that's a D. Now, all I have to worry about here is that what is the distance from D to B? This is D going to B, okay? D to B is 2. Well, D to B is 2 plus 4, which is 6. Well, D to B is 2 plus 4, that's 6. So 6 is better than 8. So I'm going to put that down. So now, so D to B would be A to C, C to D, D to B. That's how we got up the 6. Now, C to E. C to E is 5. C to E, sorry, this is from D, I'm sorry. D to E. D to E is 1. 1 plus 4, that's it, 5. 1 plus 4 is 5, which is better than 7, so I put a D there, see? Now, how about D to F? D to F, which is 6. 6 plus 4, that's 10. Well, 10 is better than infinity, so put the 10 there, okay? Put 10 there, coming from D. Now, D to G. Well, D to G is actually 3. 3 plus 4, that's 7. So 7 is better than infinity. Okay? Now, D to H, that still stays as infinity because there is no direct link. So now I have 6, 5, 10, 7, and infinity. I'm going to bring down the 5. Okay, I'm going to circle that, box it, and I'm going to put E here. That's the vertex. So now, let's see how we get from E to B. This is E to B. That's no direct link. Leave your 6 there. Okay. D to, so I'm going to go to D to F. D to F. D to F is 6 plus 5. That's 11. Well, I have 10. Leave my 10 there. Okay. Now, how about D to G, which is 3? 3 plus 5, that's 8. 8, I have 7, so I'm going to leave this 7. Okay. Now, D to H, there is no direct link. That's infinity. So now I have 6, 10, 7, and infinity. 6 is much better. I'm going to box it. And that's going to be B. See that? That's going to be B. Now, what's the distance from B to F? B to F, that's 13. Plus 6, 13 plus 6 is 19. I have 10. Leave my 10 there. That's much better. Okay, that's cheaper. Or less cost, least cost. B to G. How about B to G? There is no direct link, so I have 7, I'm going to leave it as it is. How about B to H? That's still infinity. See that? That's infinity. Now, I have 10, 7, and infinity. I'm going to bring down my 7 because I'm going to box it, and that's going to be G. That's my value for G. Okay, now what's the distance from G to F? G to F is 6. 6 plus 7, that's 13. I have 10. Leave the 10 there. Okay, G to H. G to H is 6 plus 7. That gives me, so G to H is 6 plus 7, that's 13 from G. Okay? So basically, this is where we stand. Now, I got a 10, I got 13. I'm going to bring down the 10, and I'm going to box it, and that's going to be F. Now, what's the distance from F to H? From F to H, that's 3. 3 plus 10, that's 13. I have 13 there. I'm just going to leave the 13. Okay? Well, what I can do here, I can bring down my F because that's the latest one. That's 13 because F to, I need to erase this one. So this is F to H. F to H is 3 plus 10. That's 13 from F. Okay? Now, all I have is the last node here, that's 13, that's the last vertex, if I box that, and that would be H. I'm done. So let's see, the way to calculate the cost, the distance, is by going backwards. So I'm at H. How did I get from to H? Through F. When I went to F, I got 10, and so 10, that means it's a D. So I can go to D. D takes me, the cheapest one here is C, so that's a C. And then C takes me to A. So this is actually my total cost. So now, what's A to C? A to C, in this case, it's 2. C to D, which is 2. D to F, that's 6. F to H, that's 3. So this becomes 4, 10, 13. So my total is 13. So as you can see, the best way, you go A to C, C to D, D to F, and F to H. See, that's why this is known as a single source, from A to H. So A to C, C to D, D to F, F to H. And that's it.